Hello everyone. So let's start fully convolution network. Before understanding fully convolution network that is being used for the semantic segmentation, let's first understand some. Let's just go through VGG16 network. Okay, all right. So this is a VGG16. So what VGG16s were used for? This was mainly used for image classifications. So you have a certain image, you have to tell key which class does this image belong to, whether this image belongs to cat, dog, lotus, and all. Like this is mainly being designed for the classification purpose. Just go through. Let's go through the architecture once. So that we can understand ki what actually has been changed in this architecture to make it suitable for the semantic segmentation. So the initially you had the input size of let's say 2 to 4 cross 2 to 4, and I'm considering it to be grayscale channel. So let's say there is only one channel out there, or you can consider 3 for RGB doesn't will not change anything else over this. Then we applied 2 convolution. Then after that we applied 1 max pooling followed by 2 convolution, then again max pooling, then 3 convolution, again max pooling, then 3 convolution, again max pooling, then again 3 convolution, after that max pooling. What happened after this layer? After this layer, what the output shape we were getting? We were getting the output shape of 7 plus 7 with 512 layers out there. Okay, 512 layers out there. And what actually after this we were doing? We had this 7 plus 7, 512. We cross 512. All right, we used to flatten this. So what is the meaning of flattening? He flatten all the pixel values. So there is how many pixels value out there? 7 into 7, that is 49 into 512. That is roughly, I think it's get around let's do it, 7 into 7 into 512. So this is 2508. So when we flatten it, then we get the all the pixels. We get 25088 pixels. After that, what we were doing, we applied fully convolution, like fully connected layers, or dense layers of, like, there are dense layers, and there how many nodes are there? There is 4096 nodes. uh, the paper has used two nodes, 2 layers. So again 4096 dense layers, so that all the outputs, we can map it neural network. And after that, so the paper in which the VGG16 was being trained on, that was on imaginary datasets, and imaginary datasets have 1000 classes. So in the outer layer we have 1000 nodes, and these 1000 nodes, each node we're telling what is the probability of this image being belonging to class 1. This node will gives the probability of which class does this, like what is the probability of this class image being belonging to class 2, and so on. And this outer layer is customizable. Like suppose I'm working on a binary classification task. I have an image that I have to classify it as cat and dog. Then in the outer layer we put only two nodes that tell me the probability of this image being belonging to cat and dog. So this is the architecture of VGG16. uh, but why this network is not able to segment the image? Because the design of this whole network is being designed only for the classification. With this network, with this neural network, we're unable to do semantic segmentation. Why? Because in semantic segmentation I do not only want what of the image, we also want where of the image. If you will observe carefully what this basically, let's say this is VGG16, all right, VGG16 ka pura architecture, and here is my image. VGG16 we're telling what is in the image, whether dog is in the image, where cat is in the image, where some sort of flower is in the image. But it was not telling me ki, okay, this image contains dog, but where in this image does this dog belongs? Whether it belongs to this area, whether it belongs to this area. VGG16 is unable to answer this. So the papers have come up with the approach by some sort of changing the outer layers in such a way he models gets to learn apart from what is in the image, where is the location in the image where that particular class belongs to. So let's suppose I have an image, and let's suppose here is cat, and here is dog. Here is dog. So what we want is, we first want ki, okay, you have to tell me ki there is a cat also, and where is the cat, and also you have to tell me ki dog is also present in the image, and where does the dog belongs. So observe carefully. This, whatever the bunches of convolutions that we are applying, this is going to learn what is in the image, what is in the image. So we have to come up with some sort of operation that can also give us the idea of where part. It should answer the where part of the question. Where is in the image? Where does this class belong to this image? So let's just dive into a little bit detail. You had an image, and you were when you were applying convolution operation. Let's say convolution 2D. Okay, then you reduce the size. You reduce the size of the image. Um, and further, if you will go to VG16, you had this bada wala image, जिसका size 2 to 4 plus 2 to 4 plus 3 था. And after applying VGG16 up to this layer, let's only come to this layer यहाँ तक, ये मेरे पास क्या निकाल के दे रहा है, 7 + 7 + 512. सो इफ यू विल नोटिस कि जो इतना बड़ा बड़ा वाला पार्ट है, उसका जो डेटा है दैट हैज गॉट स्टोर्ड मे बी इनटू दिस लिटिल पार्ट, दिस वाला डेटा हैज बीन स्टोर्ड इन दिस पार्ट, दिस has been data has been stored in this part, and this information of this pixels have been stored in this. So this convolutions operations were telling us what is in the image, what is in the image. Convolution tell us what is in the image, but I want to know from this output where is in the image. Like if here is a cat, then this area must contain information about the cat. So what I want to apply some sort of operation such that it gives me the information about this locality, about this area, and that operation is what we called convolution transpose. So we were first we were doing convolution to reduce the size. Now what we are going to apply, we are going to apply convolution transpose. I'm going to give you a little bit idea if you don't know what is convolution transpose. To back to convert it into this size, 7 plus 7, 2 to 4 plus 2 to 4 of the same size as of the image. And what will be the channels of this? So it basically depends on how many classes do we have in our datasets. This VG16 was trained like on the fully convolution network, that was basically trained on Pascal datasets. Pascal, it was basically a dataset that contains object detections images. So Pascals have 21 classes. So what this convolution transpose do, after resizing it, it have 21 layers, 21 layers ऐसे करके 21 layers है. So that what happens कि जो first layer है, it tells me about the class 1, कि class 1 अगर है तो class 1 में यहाँ पे हो सकता है कि ये cat belong कर रहा हो, and this gives me information about class 2 and so on. So this is the idea that the paper has taken. The convolutions give us the answer of what can we do to get the answer of where, because this what basically the semantic segmentations performs. So just if you don't know what is convolution transpose, for those this is exercise. Otherwise, if you know, you can just skip it. So like suppose you have matrix 0 1 2 3, okay, and you have a filter size of filter of let's say 1156, and instead of doing convolution, what you want is you want to apply convolution transpose. So what here you do is you first element wise multiply this input, this pixel value with all of the kernel inputs. So what you will get 0 0 0 0, then multiply 1 with all of them, what you're going to get 1156, then multiply 2 with all of them, you're going to get 2 2 10 12, and same with 3 3 3 15 18. So have you seen, you had initially size 2 plus 2, this was your input, and what you get output as 4 plus 4. This is convolution transpose do, nothing big else, that's it. So this was the idea that the paper has taken. So what happens, like what the paper has done is they have taken कि VGG16 का यहाँ तक ले लो आप, ये पूरा आर्किटेक्चर यहाँ तक आप लो. After that, the thing that we were doing, ये जो flattening operation अपन कर रहे थे ना, after this flattening, after that we were doing the dense layer, we are not interested in this, just don't do this part. Instead of what you are going to get, I am telling you, for this I am going to call this as VGG16 prime. Okay, so keep that in mind. So this VGG16 का prime के अंदर, this was my model, मैं इसमें अपना इमेज दे रहा हूँ 2 to 4 cross 2 to 4 cross 3 RGB channel, and the output that is going to give me is 7 cross 7 cross 512. So यहाँ पे now यहाँ पे what I am going to do is I am going to apply conv 2D transpose operation, जहाँ पे the kernel size would be, I guess the paper has taken kernel size to be okay. Before applying convolution transpose, what these guys were doing, let me also tell you that. One more thing. After this, before applying convolution transpose, we're going to apply convolutions of 1 plus 1, filter size 1 plus 1, and because we had 21 classes, we are going to have 21 filters. So what is going to be the output shape? The output shape is going to be 7 cross 7 cross 21. You can verify with the formula that we had. Input minus output size would have been input plus 2 times padding minus filter का size divided by stride and plus 1. यहाँ पे input size is 7, we are not applying any padding out here, and kernel size is 1, stride is also 1, and plus 1, so the output shape is 7. So just for the cross verification. So what this 1 plus 1 convolution has done, it has reduced the number of features to 21. Why 21? Because the ImageNet datasets, sorry, in the Pascal datasets we had 21 classes. So after this 7 plus 7 plus 21, After this 1 cross 1 convolution, here we are going to apply convolution 2D transpose. So if you are going to apply convolution 2D transpose with kernel size, I guess the kernel size was, let me verify it. Yeah, so the kernel size was 64, and stride was 32, and uh, padding is 16. All right, padding is 16, and from the formula, for the convolution, what the formula we were having: input multiplied by input plus 2 times padding minus filter size divided by stride plus 1. So for the convolution 2D transpose, what the formula will get changed? Just interchange O and I. So this will become I, and that is O, and just bring all of these things on the LHS. Then you are going to get I minus 1 multiplied by S minus 2P plus filter size. That is going to be the output. So apply this. इनपुट साइज हमारे पास कितना है 7 -1, stride is 32, padding is 16, filter size is 64. So if you will do, this is becoming 64 minus 32, 32, 32, and plus 6 into 32, that is 6 6 to 12 का 2 192 192 plus 32, you are going to get 2 not 2 and 2 to 4, you are going to get 2 to 4. So the output shape will going to be 2 to 4 plus 2 to 4 plus 21, because the convolution to the transpose with the filters, number of filters is also 21 you have taken. So basically what happened, this fully convolution transpose, you had this input size 2 to 4 plus 2 to 4 plus 3, you applied VG16 prime model, where you detach all the fully connected layers, you get this shape 7 plus 7 plus 512. After that you applied 1 plus 1 convolution, you reduced the number of features to 21 by 21, because this is the number of classes that we are interested in. Then you applied 2D operations with these parameters, and finally you have got uh, 2 to 4 plus 2 to 4 plus 21, the shape. So what basically this is going to tell, so there are 21 layers out there. The first layer is going to give you information about um, class 1, second layer is going to give you information about class 2, and so on. So up to this point, like up to this convolution, the model has learned what is in the image. After this part, the model has learned where is in the image, has answered where is in the image. Is it clear? All right. So just let me go through once the paper. So if you will see this, um, uh, so yeah, if you will see this part, there is 21 uh, layers, and if you will stack them all, then you can see कि यहाँ पे dog इस तरह से है. Dog has segmented with blue color, the cat has been segmented with this brown color, and the backgrounds are green and black out there. I will come to this. There is one more thing out there that I have to explain. So what is happening basically? Now let's go into the paper has described FCN 32S, FCN 8S, and FCN 16S. So uh, yeah, okay, I think यहाँ तक अपन करते हैं after this.